Section 4, electric resistance. Resistance of a wire depends on the conductivity of the material used in the wire. That is, how well it conducts, and also on the thickness and length of the wire. So we should have that down by the time we get through this lesson. Let's see. The amount of charge that flows in a circuit depends on the voltage provided by the voltage source. The current also depends on the resistance that the conductor offers to the flow of charge, the electric resistance. So what is resistance? Resistance just slows things down. It converts one type of energy to another type of energy. Remember in my analogy of the river, where you're going from a high elevation to a low elevation, that's what causes the flow of the water, the river. Well, if the flow of water is the current, the difference in elevation is your voltage, then the little rocks scattered along this river are going to be your resistance. The water's going to flow, it's going to hit a rock, which kind of slows down the flow of that water. It doesn't stop it, it just moves it along. Some of that kinetic energy is converted into thermal energy. So the energy is converted into another type through a resistor. For a given pressure, more water passes through a large pipe than a small one. Similarly, for a given voltage, more electric current passes through a larger diameter wire than a smaller diameter wire. Fatter wire, more flow of electrons coming through. A simple hydraulic circuit is analogous to an electric circuit. So for the circuit, we have a dry cell, the battery, the voltage source, and then we have a switch. When the switch is open, no electricity can flow. If the switch is closed, then it can come over to the resistance. For a hydraulic circuit, you have a pump pushing water, and then this valve. And this valve you twist off. It's like the spigot outside of your house for your hose. So if you twist that, then no water comes out. But if you open it up, then water is free to flow. And then when the water's coming through your hose, you can partially cover it up with your thumb, right? And what that does is that decreases the area for the water to flow through. So that creates a higher pressure. The resistance of a wire depends on the conductivity of the material in the wire, and on the thickness, and on the length of the wire. So, just like a light bulb in a circuit is going to provide some resistance to the current, the wire itself is going to offer some resistance. It's going to steal some of that energy, and it's going to turn it into thermal energy. Connect the negative terminal to a positive terminal of a battery with a naked wire, and then you're going to feel that wire really heat up. And that's because the resistance in that wire is converting the electrical energy into thermal energy. Thick wires have less resistance than thin wires. It's kind of like when you're going through the halls during a class change. Everybody's crammed in there together, right? Meanwhile, if you go out in the middle of class, things are wide open. Or in a driving situation, when you've got two lanes right on top of each other and it's not a whole lot of room compared to a wider driving area, and you've got a nice median, got more room to breathe, right? You can flow easier. Longer wires have more resistance than shorter wires. If something has to travel a longer distance, it's going to lose more energy. Electric resistance depends on the temperature. For most conductors, increasing the temperature increases the resistance. The resistance of some materials becomes zero at very low temperatures. This is called superconductivity. This is a newer form of physics and is used to make a lot of, or is researched to make a lot of really cool things. Check out the videos. Certain metals acquire superconductivity at temperatures near absolute zero. Absolute zero is the temperature at which all molecules stop moving. So even at really cold temperatures, if you think about your freezer, the water molecules inside of the ice are still vibrating back and forth, but not very fast. As the ice molecule, or as the ice cube heats up, they gain more and more and more and more and more and more energy, so they're moving back and forth a lot faster, and then the ice melts. Well, at 0 Kelvin, there is no moving back and forth. It's just frozen. There's no motion within the molecules. Superconductivity at high temperatures, anything above 100 Kelvin, which is above 373 degrees Celsius, has become found in a variety of non-metallic compounds. In a superconductor, the electrons flow forever. What factors affect the resistance of a wire?